Well, good morning and welcome everyone from my side. I'm very honored to be here today to speak to you. It's been a long time for me that I've been in this very room here. I guess that was at my graduation. But yeah, it feels good to be here again. About half a year ago when I submitted my talk for VIScon, I thought I would talk about security and privacy challenges when developing apps, and did that for the security track. Now, since I'm having the honor to hold this keynote and give a talk to everyone here, I did change it up a little bit, and I'm going to make it two parts. So first, a little bit about myself, but then I'd like to talk to you how we actually got here. I mean, me, myself, starting at ETH and then later now working at Ubique. And what was the road that brought us here? How it all started and how it's going now. I'd like to share some insights. And then I still want to make it a bit more technical. I'm going to go from theory to practice because there's a lot of things that we learn at ETH as computer science students, and while you're sitting in a lecture, it's often not clear what exactly you're going to use later or how you're going to apply this in your work life. And now looking back at the past 10 years, I try to remember some of the things which I learned here and how we actually put them to practice and use them in apps that we develop now. So I was already introduced. I'm the co-founder and CTO of Ubique. I did study here computer science at ETH with specialization in information security. Not sure whether this track is still called the same. This is my email. Don't hesitate to drop me a line afterwards or get in touch, or actually just come by, swing by our offices down at Central. Come for a coffee or a beer, depending on the time of day. Well, actually, who is Ubique? I guess some of you might know us for one or multiple of the apps that we are developing. I'm sure your smartphones might have one or multiple apps on them, even if it's just the one on the lower left corner which you use today to get inside this very building or room here. There's of course more, but I just tried to, the slide would overflow if I showed them all. But how did this actually start? And for us, this started in 2007, and this was when Steve Jobs first presented, or then, well, actually I have to hold it like this, introduced the first generation iPhone, a smartphone with multi-touch screen and cellular and Wi-Fi and Bluetooth, a lot of things which were not known in phones before that. It did have an ARM CPU which was able to drive this whole phone, back then with just one core and 400 megahertz, which was not a lot. Also, memory and storage, obviously, it was not the same as it is nowadays. Here it still says 8 gigabytes on this phone. Until then, people used feature phones. Do you actually still remember feature phones or even owned a feature phone? Hands, yeah, okay, all right. But time will come when people actually don't remember them anymore, and we're just used to smartphones now. Back then it was, for example, one thing I remember, it was hard to browse the web. Phones before, some of them did have the capabilities to browse the web, actually called web pages, which were specific, very small websites that could be browsed, but not the same as on computers, obviously. So this was a big leap forward for everyone and for us as well. And me and my friend and co-founder, we were one of the first ones who who imported this iPhone, the first generation iPhone, which was only sold and available in the US back then, in 2007. You could order this on eBay. It wasn't as expensive as this rare collection item here, but it was possible to get it over here in Europe. And when we were sitting in the lectures and suddenly found out, oh, look, we've both got the same phone, we joined or teamed up and looked at what could be done with it. And back then, that meant we had to use a jailbreak which used exploits in the iPhone operating system and to unlock the baseband so that it could actually be used in Europe because it was SIM-locked to AT&T. Also, apps didn't exist like this. Apple first envisioned that people would just use web apps, and they didn't provide any SDK to develop apps. But some people in the jailbreak community then came up with a solution for this. They provided an open toolchain, which was basically a GCC compiler, which could be used to develop apps for this ARM processor. And so that's what we did. During lectures or in our free time, we did start to develop little tools that helped us in our daily lives at ETH. This is then how we started this first application. Back then we called it SMS ETH. It was only available on these jailbroken phones. There were a couple of people at ETH who imported it apart from us, and we did put it up on a website. It could be used to send text messages. Back then, text messages cost around 20 Rappen for each message, and I guess around 160 characters could be in there. For students, thankfully, we had a service which was provided by the Informatikdienste, sms.ethz.ch, and through this website, you could send text messages for free. So we came up with an iPhone application which allowed us to directly send text messages, but for free, obviously. Then another feature this app included was the lunch menu at the Mensa here at ETH, or VPP, which we used to print out documents before going to the lectures. Well, actually, a fun fact which you probably see up there, the Edge icon on the screenshot. Back then, this phone didn't have 3G, while other phones already did have 3G, but the iPhone only had GPRS or Edge connectivity, and the web or browsing the web did feel actually very fast with Edge. And nowadays, I think everyone knows, or you feel the same, when we actually have Edge, it feels very slow. But yeah, times change. From SMS ETH, we later got to Pocket ETH, because the year afterwards, Apple announced the iPhone SDK. They provided an app store, and people could now develop apps officially and distribute them through the app store. So we did change up the app a little bit. We did extend it with locations, people search, and things like this. And we got in contact with ETH, who we could sell this application. I mean, selling in a sense. Our deal was we gave them the application and they sponsored 2 new next generation iPhones, which was everything we wanted. So. I think SMS ETH in the meantime was discontinued because no one is using SMS or text messages anymore. Everyone is using iMessages, WhatsApp, and all of that. So we did also remove it from the app. Another thing we did, actually, during our lectures, we were actually allowed to do that, was the ASVZ application. And we did start in the distributed systems lecture, where we actually were supposed to use a Nokia N95 smartphone to develop apps in our practical exercises. Soon after that started, we went to our teaching assistants and asked whether we could actually use our iPhones and do the exercises on them. And since we were allowed, we started with the ASVZ application, which was the next thing that helped us during our daily lives at ETH. And this is how we then got to the ASVZ app, as you might know it, or maybe not, but this was the original design. It does look a bit different nowadays, but it still does similar things. Well, and soon after releasing the iPhone app, we then also realized Android was a market, and we did also have to provide an Android app because many students already owned an Android phone and not just an iPhone anymore, which is what we did a year later. And after that experience, we did realize that this was still during our studies at ETH, that for our job, we didn't really want to be a small cog in a large wheel at some corporation, but we actually liked doing what we were doing. So we took the next step, which meant we incorporated our company, Ubique, and started professionally. Well, as for a lot of companies, this had to start with a garage feeling somehow. Previously, we did develop things in the CAB building or maybe at home in our flats, and at some point we got the opportunity to rent a small room about 10 square meters big down at Central, where we could hack the apps together in between the lectures and going back and forth between ETH. Now, I guess this is a question which might be interesting to look at. The road to success, or at least for us, maybe looks a bit like this. I'm trying to remember things here, but this is by no means a complete list, obviously. But for us, we started with small student projects, as I explained before, and things got more complex in the meantime, and nowadays we are developing apps for millions of users. Back then, iPhone apps often had an informational character. You could look up some information, but you couldn't do much more. And nowadays, when you look at iPhone applications, or in general mobile phone applications, you can use them for everything, whether this includes payment and other more complex features than we did back then. For us, we did a lot with learning by doing. This making mistakes obviously was important. We bootstrapped the whole company from scratch, and we never got any funding or investment or advisors on board, but we just tried to do things and maybe walk into a wall, but then recover and learn from it. And in our case, often one case led to another. So we started with one application, we did maybe an exceptional job, or some people recognized that what this app does is great, and they wanted something themselves which looks similar, so they got in touch with us. I'm going to share an example afterwards. Obviously, during the past, I think, 11 years, we did have ups and downs. It's not always easy to plan everything ahead, especially with the workload that you're having. Sometimes projects are too good to be passed up, and so you take it, even though you know that you're already full and fully booked, which is not easy. And then sometimes we did plan something, but a deal fell through, and we suddenly had more time at our disposal than we planned. And we did actually use that time as well and created something on our own. We did look at an idea which we wanted to do for a very long time, and then actually developed an app for that. In retrospect, it's probably difficult to say whether this was all coincidence. Was it luck, or was it just the right timing, or all of that together somehow? But something which I'd like to highlight is, I think it all came down to our amazing team and the people which we gathered around us, and we could achieve a lot of things with this. An important fact that we realized helped us to develop great apps is you should identify with your product and what you do. This really helps when you're a customer of the product that you're actually developing in a lot of ways, whether this means usability, user experience, when you use the app every day yourself. And for all of our products, we actually do feel like it is our baby, even if some company comes to us and wants us to develop an app for them, but in the end, it's our baby, and we want to push this app further. We did work hard a lot in these past 11 years, but we also had a lot of fun, and I think this is important. Now, an example of how one case leads to another was maybe this one. Back then, 10 years ago, Mobiliar started to develop an app together with the insurance lab here at ETH, part of MTech. Their developer, at some point, stopped responding when the Arab Spring started in Egypt. So they were a bit in a pickle, and some of them at the insurance lab remembered that at the student project which we did together, that we just recently founded a company, and they contacted us whether we could help out with developing this app. So we jumped aboard, and we did develop this weather app for them. It did have a radar with rain, and for this they needed data, and the data then came from MeteoSwiss, because MeteoSwiss provides and sells this data to companies. Now, fun fact about the end of the project, when we finished the app and put it to the store, we went to celebrate down to the lake of Zurich, and it was summer, everyone had shorts and t-shirts, and we did see that some clouds were coming up, but we did have our app now, and we could see that the rain is coming, but the prediction of MeteoSwiss told us that it's probably going to pass by, maybe just by a few hundred meters or so. So we were quite confident to stay, and while everyone left. In the end, we got soaked a lot, and we were completely wet because the prediction wasn't as accurate as we thought it would be. This obviously got better in the meantime. But so from developing this app, MeteoSwiss knew about us, and we did have a good collaboration, which later then led to us developing the first MeteoSwiss application, back then still in this nice blue look. So this is one of the examples how we came from one case to another. Now, in the meantime, I mean, before I told you about how it all started, and now how it's all going. We did grow a bit from 3 when we started. We're about 50 people now. Some things did have to change for the good. I mean, we did have to change things, obviously, when growing. Some things we try to keep the same, like culture or the spirit we had. Obviously, when you're more people, you can do specialization. Some people can actually focus on something, and not everyone is doing everything anymore, which was the case in the very beginning. Also, it got harder to align all the people. Back then, when we were 10 people, it was easy to talk with each other in one room and have everyone know what we're doing and actually know everything we're doing. Now, it takes a bit more time to align everyone, and yeah. Then We also had to get out of this 10 square meter room. It was at some point just too small for us. And so we did try to find new offices around Central. One is actually right above the Polyban, as you can see here. So you're probably going to pass by every day when coming here. We never had a time when no one of our team wasn't studying here at ETH, so it was important for us to be close to ETH, that we could go back and forth between lectures and work easily, and also be close to Zurich HB because we have a lot of people who commute to Zurich every day, so this helps. Now, things also changed a bit from this very first iPhone and now the latest iPhones that were presented a couple of weeks ago. When we look at that, the multi-touch screen is still there. It's an OLED screen now. Connectivity increased a lot to 3G, 4G, or even 5G. We did get Wi-Fi 6 and Bluetooth 5 and ultra-wideband and a lot of new features. The CPUs obviously also got faster. We did get more memory and disk size. So a lot changed in these past 10 or 11 years for us and also with smartphones. But this change also means that it's still interesting and keeps on being interesting for us. It leads to new possibilities with new sensors and more power. So now from how it's going, I'd like to go to the next part of my keynote, from theory to practice. And here I want to remember some things that we as a team learned at ETH and are now using in our apps, as I mentioned previously. The computer science colloquium here at ETH gives us a good foundation, and it does provide us with a way to think and a way to tackle problems, and also obviously gives us theory of a lot of things. And as I mentioned earlier, I was always wondering which things I could use later in my work life, and now I'd like to give some examples. But there are some things which we don't learn at ETH, and as I mentioned before, we did learn these things just by doing. So project, people, management, business aspects even. You can just start and do this on your own. You don't need to learn this at ETH. It's not a barrier or something. The main knowledge will also come to you, I mean domain-specific knowledge, as in if you're developing a public transportation app and you have to know about how trains run and what that actually means, but this you can also learn on the job. Well, and as I mentioned earlier, during a time when we did have more time at our disposal than we anticipated, we did develop an app which we wanted to do for a long time and never actually managed, because of other projects. And this was to make a better public transport timetable app. Back then, SBB app was rather cumbersome. You had to enter stations, typing on your keyboard every time, and it was rather slow. So we did come up with the idea to connect tiles and actually set up these tiles with pictures of the stations which you use the most. Often we're doing the same journeys every day. We go from work to home to ETH and so on. So you could set this up in Viadi, and with this usability, you could make a timetable search much quicker than this was possible before. Later, this also ended up in the SBB application, as you might know it now, the SBB Touch Fahrplan, or Touch Timetable. Now, another thing we actually put behind Viadi is a homegrown routing service. So we did remember some algorithms from graph theory that we learned during our studies, and someone from our team, Simon, he recently did a bachelor thesis on a similar topic, and we said, why not? Let's try to do our own routing service and use these theories. Now, often when you study an algorithm here at ETH, at some point you think, okay, all right, I understand how this works. But then actually when you implement things and put it into practice, you find out maybe it's not as easy as I thought, or these edge cases are harder to solve than I thought. This happened to us as well. We tried to find pragmatic solutions to a lot of problems. One of them, for example, we put everything into memory and made it faster than going to a database or reading from a file all the time. We then continued after Viadi and extended it with Viadi Zero and added multimodal routing. We added taxis and mobility. We did put live positions of vehicles here in the greater Zurich area, or a zero touch timetable, actually, which predicts where you're going or most likely going today. Now, another example is visual computing. In Game Lab and other lectures, we did learn about shaders. We did use or program some of them. But later now what we did is we continued with weather apps, as you can see. This one is the German weather app. And it still has a radar, but from just putting the picture which was rendered by the Meteo Swiss or the German weather service and putting this on a map, which has a lot of pixels, as you can see on the left side. We did go further and took the raw data and we draw it down on the GPU. And we used some interpolation that we learned here in numerics lectures and made it very smooth. So no matter how much you zoom in, the radar now looks really smooth and not pixely anymore. Another example is maybe labels on a map. In the beginning, we just took a label, rendered it on iOS or Android, put it into a picture, and then gave it down to the GPU and rendered it again, because this was easier. But what we're now in the process of doing, we're rendering labels ourselves directly on the GPU by taking them and putting them together ourselves, which makes things faster and look better than before. So we do a lot of work on the GPU, and we do that with C++ because it allows us to share code between iOS and Android, and also to make it fast. Next example is probably our Open Mobile Maps SDK that we provide on GitHub for free, and you can use it in your apps. But what this actually does is it takes the maps from Swiss Topo, the Swiss maps, which are rather large, and it tiles them into small pieces, which can then be downloaded asynchronously and drawn on your phone, as you're probably used to from other map applications. Something we learn in system security is the topic of trusted execution environments, or TEE called. And on iPhones, Apple uses the term secure enclave. This is actually a feature which allows you to divide a CPU into two modes, a secure mode or a secure world and a non-secure world. And in the secure world, you can put the small microkernel and store secrets, generate secrets, safely, and provide an API to the non-secure world without having the secrets ever leave the secure world. So the API provides a way to maybe sign something or encrypt something, but it actually never reveals the secrets for that. Now, in the meantime, we did get high-level APIs on iOS and Android, whether this is in the keychain or key store API. Doesn't really matter. I did also do my master thesis around this topic, and so a couple of examples are probably our Ubique auth solution, which is a seamless authentication experience, passwordless with Face ID or Touch ID that allows you to log into websites and applications. Another example, which some might have already used, is the transfer code in the COVID certificate app, which allows you to deliver certificates safely to your phone, encrypted with keys which are stored on this secure enclave. Or something which we are currently working on for ASVZ. You might soon be able to enter ASVZ building using your ASVZ app and to show a QR code to a system which then opens the gates and allows you to enter. Then about 1.5 years ago, when this whole pandemic started, we did remember some things we learned in wireless network security. It was about ranging techniques, using Bluetooth to do, so actually using the RSSI measurements to actually estimate how far we are from each other. And so also at a hackathon, maybe like you do today, we did start to look into these proximity tracing apps, which were in the media everywhere. And we did think it is possible to develop such an app without sending all the GPS locations of everyone to some central server which stores it in a database. And actually came up with a privacy-preserving contact tracing. After that hackathon, we published everything on GitHub, and soon afterwards were contacted by our former professor, Sirjan Chapkun, and got in touch and found out ETH and EPFL were working on something very similar, and we joined up and did form this DP3T consortium, and this later led to the Swiss COVID app as you might know it now. DP3T, we did have to solve some problems which were not as easy because Apple and Google restricted some of the Bluetooth capabilities that they put into their phones. But lucky for us, Apple and Google soon afterwards also started looking into this topic, and this led to a lot of evening calls after California actually woke up, and calls at the weekends with Apple and Google to see how we can make this possible. Then, one step further, applied cryptography, which is also taught here at ETH. You can learn about the identity-based encryption scheme. And this was then the basis for the crowd notifier technology, which was, again, developed together with the same team at ETH and EPFL, which solves the problem of check-in solutions that we all came to know last year, but with most of them you entered your details and they were sent off to some server and stored in a database. And we did want to provide a solution, a privacy-preserving solution, which allows you to scan and check in and actually get warnings, but not to reveal your private data. And this later was added to VIScon as a check-in solution. Digital signatures is a lecture which is taught here at ETH, and I also remember the Applied Security Lab in which we were securing a public key infrastructure that was given to us. Now this reminded me of the COVID certificate system that was designed or envisioned by the European Union, the eHealth network, and then later also developed here in Switzerland as the COVID certificate, as you might know it. And the key components here are actually signatures, digital signatures, which make sure the integrity of the QR code can be preserved. Now the details, maybe we can go into them in a bit, but what you're all using is a 2D barcode, a QR code, which has to be scanned by a check app. This QR code uses this binary representation CBOR web token to make it small, because this is one of the challenges we're facing with scanning QR codes. The smaller the QR code, the better and faster it can be scanned. Now, to make these signatures actually work, a public key infrastructure is needed, and in our case, the Swiss government already has a public key infrastructure which could be used, but as this was supposed to work across borders in whole Europe, there needed to be a gateway where these public keys can be exchanged. And so the EU provides an EU gateway, which is then used by all the countries to distribute the signing certificates, these document signer certificates, which are used to actually sign the QR codes. One feature I mentioned before is this transfer code. One of the problems with COVID certificates is that you might not always get them when you do something. This might be easier in a case of vaccination. You directly get a piece of paper when you get the shot and you walk out. But imagine you do a test, a PCR test, and you go to the pharmacy, and about 12 hours later, or if it's fast, 6 hours maybe, you get the result. But how does this result come back to you? And what a lot of pharmacy and labs did was the easy way. The easy way is just use some unencrypted email and send it to you, and no one cares, right? But we did provide a solution for this, and so what we're doing here, again, like before, we do create a public-private key pair in this trusted execution environment, secure enclave, store it there, upload it to a server, and assign this transfer code to it, this 9-digit transfer code. And this allows then to receive a certificate once it's ready on the server, encrypted for just your device. So here you can see a more technical diagram of that. Step one, where we upload the certificate and the public key and store it on a backend. But the main gist here is we're using this private and public key pair on the secure enclave to make this secure. There has also been a lot of UX considerations into this transfer code, and what we're trying to solve here is when someone writes down this transfer code on a piece of paper and then later has to read this again, it's sometimes hard to read these illegible letters and get it right. So what we did is we did remove characters which look similar. We did put a checksum in the end so that it can be verified already when entering the system. Yeah. Now, as I mentioned, UX challenges, we were also facing that with making the QR code small, and this shows the process how such a QR code is actually produced. It starts with a JSON document, and trying to make a QR code small means that we have to limit the data and make sure that we're not writing too much and too verbose in this JSON document. This is also why, for example, you can see maybe TT as a test type, or NAM as a name field, or FN for first name, just trying to abbreviate things and make it as small as possible. Later, this JSON document is then used and coded in a binary version and signed in this COSE signed document, then compressed and base 45 encoded. So let's look at that. We take the JSON from before and we put it into this. This is a simplified JSON representation of this binary format. Binary is a bit hard to read, that's why I still put it in JSON, but it would look like this in a binary format. We do say which algorithm is used to sign this document up there, whether it's an RSA or an EC signature. This actually has a big impact because ECDSA signatures, which were recommended by EU, produce smaller QR codes compared to RSA signatures. So when thinking, every step of the way, we are thinking about making the usability and user experience better, even when changing little details down here. Now, after we compress this with setlib and encode it with base 45, this actually helps because the character map of QR codes actually consists of 45 letters. So it does allow us to produce smaller QR codes. And you can see the difference here between an RSA signature, which produces more data than the ECDSA version on the right side. And then, well, in the QR codes, it's a bit harder to see, but the left side does have more pixels on it than the right one. So in closing, I think I'd like to mention a couple of things, and this means finding and solving interesting technical challenges is very important, obviously. And I do think with our backgrounds, we will get this right. And we will also come up with pragmatic solutions that allow us to bring something to market faster than maybe something over-engineered. But we should never forget about the user experience. This is a very important point that we realized in these last 10 years, and it does help if you're the user yourself and using the app every day, the software that you're developing. And with that, I would like to finish and wish you a great day, a lot of interesting talks ahead, and workshops, hackathon, and yeah, enjoy VIScon.